So all you should have left to do is just finishing up the division. I'll give you a quiz review at the end, so that way you have some extra practice before your quiz. You have a lot of practice for this quiz, right? That delta math, what I gave you last time, and that quiz review. So you should have plenty of problems to get you some practice in before your quiz. If there's something that you're not quite getting, you feel like you need extra help, don't forget we have after school on Wednesday, which is today, like 2 doors down. You can always get help from an Algebra 2 teacher there. So let's look at what we have going on here. And you don't need to go in order of the question. Just look at the graphic, kind of see what you are noticing first. So did anybody notice, looking at your graph, what might you have noticed first here? What kind of just like stood out to you and you're like, oh, all right, I know this at least. The coefficient is positive?
Yeah.
How do you know the coefficient is going to be positive, Morgan?
Because both the arrows are going up.
Good job. And if both of those arrows are going up, I know my degree should be even or odd. Even. So kind of keep that in mind as you're going through trying to figure out your degree. This side's positive. Morgan said they're both going up, which talks about my end behavior. So both my ends are going to where?
Infinity.
Great. Positive infinity. So look, if that's all you recognize, look, you got like 3 things done. That's great. What else might you have recognized? What did you see, Mithra? There's 5 turning points. How did you see that? Because remember, turning points are where you change direction, right? So you're going to go, okay, like decreasing, I change to increasing here, I change here, and then I change here. Were you counting this as a turning point too? So remember, this is doing what the whole time? Increasing, but it looks like a what type of function? What type of function looks like this? A cubic function. So I see how you could have thought 5. If you count this as like 2 because it's a cubic function, so you decrease by 1, but you only really change where you straight up turn your direction, which that would be 3. So with that being said, what might you have like kind of looked for next here? Usually that's going to help us figure out our degree. Yeah, but before I say my degree, I want to also look at the roots, because my number of roots should match my degree. And where should I look to find my roots? On the x-axis, those are going to be my what type of roots? Which kind? The real ones, yes. Because I can really see them, right? So looking at my x-axis, boom, 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 I hit my x-axis first at -3. I'm not just hitting it here, meaning I'm not just passing through. What's happening here at -3? I heard a lot of good things. You bounce off of it, which means you hit it twice, which means what fancy word does that match with? Multiplicity of, yes. So that means that x equals -3. You can't just write that and say that's one root. You have to say that's a multiplicity of 2, which means that kind of counts for like 2 points when I'm thinking about how many roots will I have. And then if I keep going along my x-axis next I have x equaling -1. Does that have a multiplicity more than 1? Nope, just passing through 1 time. And then now if you keep going, I also pass through at 4. And what does it look like at 4? Does it look like I just passed right through? There's a wiggle. Remember that wiggle connects back to multiplicity of 3 because it looks like what type of function we already mentioned. A cubic. So at x equals 4, we have a multiplicity of 3. So let's count our points. I had at -3, multiplicity of 2, so that's a 2-pointer. I had -1, that was only worth 1 point. And then at x equals 4, I had a multiplicity of 3, which means 3 points. So like how many was that altogether? 6, which means that's my total number of what? degree and what else? Roots, right? Degree and roots always match. And was I able to see any imaginary roots? We got all 6 of those. What were they? They were all real.
Yeah.
I had no imaginary. I would need to know more information for me to like see if there was imaginary, right? Like maybe this was my image and I had a degree of 8, so I know my 2 remaining would have been imaginary. So I think that's a septic. I would not be so concerned with knowing the types of each of those. It's just like kind of like a learning process with us here. All right, so now what's left over? It's all old stuff. So those are kind of just all those ideas we talked about last class. So now let's just get into our old ideas. Like, what's our domain? Can we see all that? Great. And what's our range? Yeah, negative, I think it's like 170, let's call that, to infinity. And then where are we increasing? From where to where do you see that first? What do you guys see? Where did you first increase? Go from left to right.
Negative 2.
Good. And where else?
Negative 1 to 4. Or 1 to 4, I mean.
Oh, so here 1 to 4, and then I keep increasing after that, right? So it's 1 until when? Good. And then lastly, decreasing from all the way left, which means negative infinity to negative 3. And
Negative 2 to 1.
3. So remember, keep those. Always parentheses with increasing and decreasing. Alright, so what we're getting into today, kind of lots of examples we're going to be going through together today. Today's a very important day, so I'm so glad you are here with us today. And why this is such an important day is you already know we're going over division, because that's our one idea in your Delta Math that we have not quite covered yet. But there's lots of different scenarios, lots of different problems that you can kind of come across with division. And what we're going to get into is we have 2 different types of methods we'll learn with division. And one is a method you're already familiar with, which is your good old friend, long division. So to use long division with a polynomial, it's going to be very similar to doing long division with just straight up numbers, which we did with like 5th grade maybe. Something around there. So let's see these 5th grade math skills and see. You divide 597 by 4 using long division. So if you're like, shoot, man, I do not remember 5th grade math, see if you can find someone at your table who remembers 5th grade math.
Okay, I'm trying. Miss Shepherd, what's like the, it's like, it's like, no, what's the, like the acronym thing?
Somebody was asking me that earlier, and I was like, I don't know an acronym for long division.
Yeah.
Maybe we can discuss that.
Yeah,
All right, guys, let's see about if you still got those 5th grade math skills.
I don't think I should be able to.
All right, guys, let's go to second, because the steps for doing this are going to be like the exact steps that we have when we start having things look crazier, scarier, because it's going to be polynomial long division. Anybody tell us, how do you start off just long division with our numbers? What do you do, Yalda? Yeah. Uh-huh.
And then bring down the 9 4 times.
Oh, and then what did you do after this? Good job. And then you bring down the 9.
And then you get 9 7.
Yeah.
And then 4 times 4, and then that goes in 4 times, and then that way you get 3. And then you get a remainder of 1.
Yeah.
Brings back to
So it's 19.
and then 6 4 goes to 7.
And then you bring down the remainder.
Good.
The remainder of 1. 2 0 down.
Good.
Yeah.
0.5. Good. So y'all went above and beyond and converted all the way to the decimal at the end of like 0.25. What? It's because this one at the end. What does this one represent? Your remainder. So, Morgan, chill. If you wrote the answer, or if you have ever seen your answer look like R1 for remainder, we're gonna forget about that idea because that does not like show you mathematically of like what that has like really no mathematical meaning. What the one is your remainder. And it's 1 over what value? 4. So this is really 149 and a fourth, which also makes sense if you got 0.25, right? Isn't 0.25 as decimal 1/4? So let's recap some of those ideas that Yalda was saying because they're going to be the same ideas as we get into polynomial division. It was first like, okay, we knew it was 1 up here because 1 was like, okay, what times 4 could get you as close to 5 as you could without going over 5, right? And that would be 4. And then always doing what between each? What sign do you always see? Always subtraction, and then bringing it the next term down, so that way you were able to keep going and repeating that process until you got to the end, which was 1, which is your remainder. So we're going to do the same idea with polynomial division. It's just going to look a little scarier, but it is the same exact foundation, right? Find these terms up there, subtract, bring your next term down. So you don't need to write all these steps. They're on the slides that are posted on Schoology, and they're there to help you, kind of support you when you need to look back at them. We'll just work through our examples. The one thing I do want to add is that if you ever have a polynomial that isn't standard form, but like skips over a term, remember that would mean the coefficient is 0 at that place. So you would always want to add in that term, so that way your terms stay nice and lined up with your like terms. You didn't have to worry about that with numbers, right? Because if I was dividing 4 by like 501, notice my tens already has a 0 built in. So you didn't really have to worry about that when you just did long division with your numbers. But you're not going to have like a 0x with your polynomials. You just like won't have that x term. So we'll have to build that in. That's kind of the only thing that might have been a little different for the process compared to just with numbers. Remember in the end, if you have a remainder, you're going to write it over the divisor at the end. All right. So let's get into it. We have 42x to the 4th plus 3x cubed minus 9x squared minus 1, all divided by 6x plus 3. So, same idea to set that up. 6x plus 3 is our divisor. That's going to go outside here just like you did with 4 when you set up your long division earlier. Now, your numerator is what you're dividing it into. So that'll go underneath 42x to the 4th plus 3x cubed. And then notice we have minus 9x squared. And notice we don't have an x term. So remember, so what do I put instead of just x? Yeah, no x, so I do plus 0x minus 1. So you're going to want to do this so your like terms like always stay lined up.
Do you always add 0x?
If you want to subtract 0x, that's fine. Those are the same thing because they're both 0.
Okay.
It is sometimes addition looks a little nicer though, doesn't it?
Yeah.
Yeah. All right. So let's think back to long division. Back to that problem. Now it told us up here we have 1 because 1 times 4 got us as close to 5 as we could without going over. Same idea here. We want to think about, okay, well, what times 6x? And I just really think about the first term here would get us 42x to the 4th. Great job, Evan. And I want to make sure I line up my like terms. So x cubed over my x cubed. Now remember, you only got 4 down here next. We did 1 times 4, got me 4 down here before we subtract it. And we'll do that same idea, but now I'll have 7x cubed. I want to multiply that by 6x, and that's how I'll get 42, x to the 4th. And I also have to do it to this plus 3. So that'll become plus 21x cubed. Alright, so how we got this 7x cubed? Who can tell us how can we get 7x cubed again? What do you think, Yana?
That's what you mean. She like that is 6x. It's 42x.
Great job. So if your brain works well with multiplication, phrase it always like what times this value, which is 6x here, gives me my first term under here, which would be 42x to the 4th. If your brain works well with division, just divide this by that, and that's your term up there.
By what?
This, 42x to the 4th by 6x. That's what you get up here. So who remembers with long division, what do I do next? Subtract, and I forgot to mention this earlier. If you have a different colored pen or a different colored pencil, or if you want to grab one from that blue book in the back of the room, this is really helpful to have a different color right here. So why is it helpful to have a different color? So think about what's really happening is you're subtracting all of this, right? I can't just subtract the first term, I have to subtract the whole term. With our numbers before, it's just one number I was subtracting. But now it's every single term. So think about you're going to have to distribute that negative inside to both. So think about what you'll really have here. This will just become like a minus 42x to the 4th. And now I always kind of just draw over in a different color the new sign. So this will become minus 21x cubed. Think about what I did, right? Distribute that negative. So now we are subtracting, just going down at 42x to the 4th minus 42x to the 4th. What does that become? If your first terms do not zero out, double check your work. They always should. Now I have 3x cubed minus 21x cubed. What does that become? Great. And remember, it's back with long division. What would we do next? Great job. Bring down our next term, which is minus 9x squared. Now, we are back to repeating that process again. So we are thinking, what times 6x can get us minus 18x cubed? Great job. And I'm going to take that minus 3x squared and multiply it to both of these. So I now I'll have minus 18x cubed and now minus 9x squared. And what are we doing next? Well, what do I have to do with these? I have to subtract. That's a great point. So Gelda was noticing, okay, this should become 0, right? That's because I do need to subtract. What's going to happen if I subtract the negative? Yes, subtract the negative again, this will become? Yeah, so if you are someone that might make mistakes, distribute out that negative. If not, I would take like a different color and change the sign. So, what's going to happen here? Negative 18x cubed plus 18x cubed.
0.
Great. What's going to happen over here with minus 9x squared? Also 0. So, this problem just became a lot easier for us. So, because we have to distribute a negative. Did you have minus 9x squared here?
No, I thought you were supposed to multiply the 3x down to the 9.
It's a minus 3x squared multiplied to this 3. And that's how you get minus 9x squared, but then you have to subtract. So minus negative turns it to plus.
Oh, I see.
So think about, we really had a 0 here, right? Which was a 0x squared, if you wanted to kind of think about it like that. And if I'm bringing down my 0x, that's still all just really 0. Which means I'm really just still needing to bring down a minus 1. So will something times 6x get me negative 1? No, so what do you think this negative 1 represents? The remainder is right.
How about the 0x?
What was that?
How about the 0x?
Oh, 0x, that's just 0, right? So then it's just 0 minus 1, which is still just negative 1. So this problem, with these zeros happening here, kind of cut our problem in half, which we like when that happens. Like, half the work. So here's our final solution. It would be 7x cubed minus 3x squared. And how do I represent this remainder? What do you think, Delta?
Negative 1 over 6x.
Great job. Not r equals negative 1.
Why do you have to write 0x if it's just gonna be 0?
You don't. I was just doing that to show people. Like,
So, like,
if you brought it down, it's just 0.
No, I mean like in the problem.
Oh, at the beginning?
Yeah.
So, in the beginning, when we wrote 0x, it's not always going to be, like, nice for us like this. So, because I had 0 combined with another 0, like, that didn't really matter. But you'll see in the next problem why that's important. And it's going to be very crucial with synthetic division, too, that you always put in 0 for your missing terms as well. What other questions do you guys have? Got it?
Where did you get the negative 3?
So after we subtracted here, we have minus 18x cubed. So we need to think, what times 6x to get me minus 18x cubed? And that was negative 3x squared. Any other questions? All right, let's try one more time. So if I were you, I'd probably get out some paper and some notes to be jotting down, not just doodling over there. Right, especially if you haven't been here in a while. We got a quiz next time. Alright, so let's set up our division. So I have x to the 4th plus 4x cubed. And what should come next? 0. Great job. 0x squared. So what are we thinking first here? What's our first term up top going to be?
X squared.
How did we figure out x squared, Morgan?
Because x squared times x squared is x to the 4th.
Great job. That'll get us back x to the 4th. Now I'm going to keep that x squared and keep multiplying through the other terms. So x squared times 3x would get us 3x cubed. Now x squared minus 5 will be minus 5x squared. And what's happening next? Subtract. So once again, either write out parentheses with subtraction and distribute it through, or like I like to take that different color and kind of change the signs. Remember, that's what distributing a negative will do. And what's going to happen here? X to the 4th minus x to the 4th. Great. If that doesn't happen, check your work. 4x cubed minus 3x cubed, what'll happen there? Uh-huh. And then this is the part where Morgan was asking earlier about that 0. Like, let's see why it's so important here. If I did not have that, I would have had an x right here instead. So this 0 allows it to make sure I'm lined up with my term to know this is my next step really. 0x squared plus 5x squared, which should just be 5x squared. And then I want to bring down that x. Now, I'm thinking, what's my next term up top here?
X.
How did we figure out x?
Because x squared times x is x to the cubed.
Great job. And now let's keep multiplying that x through. So then you have 3x squared and minus 5x. And next up, what do we do with these terms? Subtract. So how do you change all your signs? minus here, plus here. And I know my x cubed minus x cubed becomes 0. 5x squared minus 3x squared would become 2x squared. And then x plus 5x would become, great job. And then what do I still need to remember to do? Great. See, it's just that same process over and over again. And then what's my next term up top? 2. 2 times x squared gives me back 2x squared. And then I'll have plus 6x, and then minus 10. And what am I doing with these two? Great job, I'm subtracting, so switch my signs. Minus, minus, and now plus. And what's that going to become?
0.
Great, what does that 0 mean?
No remainder.
No remainder. What does it mean if you are doing division and you have no remainder? That's a good number. We like it when that happens, right? Who else can say that maybe in a more mathy way? What happens if you have a remainder of 0?
You just write what's on your top of it.
Okay, that'll be your answer, right? This will just equal x squared plus x plus 2. What else does no remainder mean? Kind of what Vita said, it's a good number, right? Meaning, did it divide through perfectly?
Yeah.
Yes. So if you divide through perfectly, a math word for that means this is a factor. Meaning, right, like this, x squared plus x plus 2 times this was equal to your numerator. What questions do you guys have with long division? So keep your foundation of like what you did back in 5th grade as you move through with your polynomial long division. Yes. So, Yolda's asking a great question. What if here you got you like ran out here. This was x squared, right? But you got x plus 10. Would something times x squared get you an x? No. So x plus 10 would have been your remainder. And you would have had that over this. So what we're getting into next is synthetic division. If you hear the word synthetic, what does that mean to you? Yeah, it's like artificial, kind of fake. So if you see this, you're gonna at first you're gonna be like, this is fake. This is what you can kind of call like some mathematics, right? Like you're like, I don't know how this is lining up and working, but we're gonna connect it back to long division when you guys try some on your own. So keep that in mind as you're going through the steps. But with synthetic division, you can only use it in a specific case. Long division is like what you rely on and what you can use if you're dividing any polynomial by any other polynomial. You can only use synthetic division if you have a linear factor. So keep that in mind. So once again, notice write this, it's on those slides for you, but you can only do that if you have a linear factor, like something like x minus a number, x plus a number. That's what that means to be a linear factor. So I'm going to work through the problems with you and then kind of explain those steps as we go. So let's set up our synthetic division. So kind of draw like a long L that fell on its back. And when I'm drawing this L that fell on its back, kind of here's our setup. Look at what I have in my numerator. I have 3x cubed plus 30x squared plus x plus 11, and I'm dividing that by x plus 10. So I can only do synthetic division if I have a linear factor. Do I have a linear factor here? Yeah. So I have that x plus 10 that I'm dividing by. So that's like check 1, I can do synthetic division. So let's set up our synthetic division. And to set it up, I'm going to notice what's my highest degree in my numerator that I'm dividing by. 3. So kind of think about if I'm to write in standard form, I have my x cubed, then my x squared term, then my x term, then just my number term at the end. And when I use synthetic division, I'm only going to use the coefficients. So what's my coefficient for x cubed?
3.
What's my coefficient for x squared? 30. What's my coefficient for x? And for that number at the end, it's 11. If you can set up synthetic division, this is like half the battle. So x plus 10 is that factor we're dividing by. But I want to figure out what was the 0 of that factor. Meaning, if you had the factor of x plus 10, where would the 0 have occurred? Meaning, where would you like cross the x-axis kind of with that? Good, Liam. -10. So -10 out here is that number we're going to use for synthetic division. And if you're not quite sure, remember, you're going to take that factor. Option 1 way to think about it is just flip its sign. So plus 10, flip it to be minus 10. Or you can always think about it, I need it to be at the 0, which means set it equal to 0. So you know that number you're using for synthetic division is -10. Meaning if you're reading those directions for the steps, that's like your A value. Alright, so if we got this set up, that's kind of half the battle, like I said, with synthetic division. Everything else is just doing 2 things, which is multiplying and adding. So, let's get to it. Once you have your set up, you're always just bringing down your first coefficient. So bring down that 3 first. Yep.
Does this only work if it's an x, or will it work if it's like x squared or x squared?
Alright, who can answer Cash's question that we said? He said, does this only work if it's an x, or could it work with like an x squared?
Yeah.
Yep, only works with the linear factor. So that's why we can do this, because it's x plus 10 that we're divided by. Devin?
Can you just do like long division one?
So, yes. So what I'm saying is, if long division is your jam, you can always divide by long division. If you love long division, keep doing that. But I think synthetic division, just give it a chance, because you're going to see if you have a linear factor when you use synthetic division, it is going to take you half the time of long division. It's going to go way quicker. So it's just new, so it's like a weird setup right now. But give it a chance, you'll see it'll go much faster. So you're just doing 2 things. Remember the 2 things I said? Multiplying and adding. So you bring down your 3, your first number, and now you're multiplying 3 times this value out here, which will give us -30. And now you're adding. You're adding 30 and -30, which will give us what?
0.
There we go. And you just repeat that over. So, to get back up here, I multiply by the value out here, which is -10 times 0, which will give me 0. Now to get down here, I just add those 2 together, so we'll have 1. Now, once again, let's get back up here. We're doing that by multiplying by -10. So I know -10 times 1 is -10. Adding them together, we'll end up with what at the end? 1. And this value you get all the way at the end is going to be our remainder. So this value all the way at the end is your remainder. So does this divide perfectly? No, because we had a remainder of 1. So You already know how to kind of write the remainders answer, right? At the end, I'd have 1 over what I was dividing by, which is x plus 10. Let's talk about the rest of your answer. The rest of your answer comes from these numbers here in red. 3, 0, and 1. So what do you think your first term might be? I think you got a 3 down here. Yes, Arch. 3x squared. How do we know it's x squared? Yes, x squared is like kind of your next highest. Because what did you start off with? What degree? 3. And if I was dividing by an x, think about what you do with your exponents. You subtract. So go down by 1. So then I know, basically, my values here, whatever your highest degree is, here I wrote 3. This, for my first answer, it'll be in standard form for you, and this will be your x squared, like the next highest degree. And then what would come next? 0x, which do I need to write that? And then lastly, just plus 1, and then plus 1 over x plus 10 is my final answer. All right, what questions do you guys have? So like I said, let's try another one with synthetic division. Once you start picking it up, it will go much faster. So let's try another problem.
Miss Shepherd, what if it's like 3x minus 2? Can you still do it?
Great question. If it's 3x minus 2, like that you're dividing by, that is technically a linear factor. But what would, think about setting it equal to 0. You would add 2 divided by 3. So 2/3 is that number you would have to do synthetic division with. And if you are loving fractions, you can do that, right? Because you'll have to add and multiply potentially with fractions. And if you feel comfortable doing that, go for it. If not, something like 3x minus 2 that you're dividing by, what might be a better route instead? Think about you're dividing by 3x minus 2. If you don't like fractions, what would be a better route for you instead? Yeah, good. So let's set up this problem with synthetic division. So draw our L that fell down, and think about my highest degree that I'm dividing by. My numerator is 3. Then I think about squared, then x, and just my number. So let's put our coefficients underneath. What's my coefficient in front of 3x cubed? 3. What about for my x squared term? Good. What about for my x term? And then my number is 2. What's my term that I'm going to use synthetic division with? Good job. Flip that sign. All right, like I said, set it up, half the part. So we got the setup done. Check. What's step 1 of the setup? Bring down this first number here, which is 3. Okay. How do I get to my next space up here? Great job. 3 by 2 is going to give us 6. Now, what do I do with 0 and 6? Great. And then we're just repeating that process. So that'll become 6. Now we'll do my next space up here will become what? 12. How do we know it's 12? Great job. Add those together and we'll get 6. And then lastly, we'll have 2 times 6 again for 12. And what did you find your remainder to be? So does this divide perfectly? No. Remember, my remainder would be what for it to divide perfectly?
2.
Great. So, what is our final solution using these values? What's our first term if I have 3 here?
3x squared.
Great. 3x squared. Then, what's our second term?
6x.
And then,
Plus 6.
and then my last,
Plus 14 over x.
great job.
Do you like have to do anything to the remainder because there's like a 14 and a 2?
Oh, like, should you express it as,
Like, do you feel like no? Okay.
because it's one term over two terms.
Okay.
What other questions do you guys have? Are you ready to try? This is practice. So I'm going to give you one problem, and I want you to try this problem using both long division and synthetic division. So think about right now, what method do you feel more comfortable with? Try that first, and then use the second method. And remember, you should get the same answer because it's both division, it's just doing it in a different way. To check your solutions. So once again, you're dividing just two different ways to do it. So you should have got the same thing in the end. So notice here how the numbers you get from synthetic division, where they show up with long division, right? This minus 12 is where you get this value from right here, right? So that's why when you're adding them together, right, or subtracting, you're getting that same thing. And then here, this 32 is coming in right here with that x. And then lastly, this minus 20, kind of see how those are all matching up the same. So just kind of thinking about and reflecting on like where you're feeling more comfortable with like at the moment, and kind of knowing the other one is kind of where you should maybe focus more your attention and practice with before your quiz. So did you get a remainder of negative 121 and start to question yourself like, man, I messed up somewhere. This is a weird number. Kind of, yeah. Anytime you get like a weird number in math, like if you're like got like x equals like 172, you'd probably be like, it just doesn't feel like this should be the right answer. I think we've all been there before. So you got your remainder of negative 121. We're like, I don't know if I did this right. Do I have a theorem for you? So what this theorem is called is your remainder theorem. So what your remainder theorem says is no matter what type of division you do, if you're dividing by a linear factor, like we are here with x plus 4, notice here I got my remainder of negative 121. Notice this is what our remainder theorem says. Kind of think that number I would have used synthetic division with, which would have been negative 4, kind of what would have made this value 0. If I plug that in to that polynomial I'm dividing into, that is going to equal the remainder, negative 121. Cool, right? So that's like a good way to check to see after you got the remainder if it was indeed correct. So here's what our remainder theorem does and how our remainder theorem can help us kind of solve problems even more. So if a polynomial is divided by some linear factor, like x minus a, that remainder will equal when you plug in that a. So kind of think about same idea. That value used for synthetic division, where you flipped the sign, plug that in, and that will help you find the remainder. So it can really help us determine if this factor is going to be a factor. Because if I plugged in like this factor here, how do I know I am a factor? What will the remainder equal? Think about what would your remainder equal if you are a factor? We talked about that before. 0, because it does divide perfectly. So that is going to help us to factor completely or keep factoring polynomials, because we're going to get to the point where we're like, we'll try and factor maybe from the beginning, but we're not going to be able to. But this will help us keep factoring and eventually solve those polynomials as well, which we'll get into next week. So here we have x cubed plus 3x squared minus 4x minus 12. And I want to figure out if x minus 2 is a factor. So a couple different ways you could approach this. How can I figure out if x minus 2 is a factor?
Synthetic division.
Good, so option 1, I can do synthetic division, right? So I can do synthetic division, and what my remainder needs to be for it to be a factor.
0.
Great job. So you do synthetic division, your remainder equals 0. What if you hate synthetic division? What's something else you could do? You could do long division, and same thing, you would find your remainder would equal 0. But if you hate all division, and you don't want to do synthetic or long division, what else could you do? You're not out of luck. You can use your remainder theorem. What does your remainder theorem tell you you can do?
Plug in the x on the denominator and see if it.
Yes, plug in kind of. What would I have to plug in for x based off my denominator?
2.
2. Remember, flip the sign. So it would be, if I plug in 2 into the numerator, that polynomial, so I'd have 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12. So if I plug this in, then I can use that remainder theorem to tell me if it is a factor. So think about what we'll have. We'll have 8 plus 12 minus 8 minus 12. And what will that equal?
0.
So if I equal 0 here, based off the remainder theorem, what do I know? It is a factor. So this means my remainder is 0. So therefore, yes, it is a factor. So that's how you can use your remainder theorem. All right, similar question, different values. So pick a way that you want to determine if this is a factor, and we'll see what you found out in 2 minutes. All right, looks like some of you are starting to wrap up, but if not, you can kind of continue to work it out as we're talking. Anybody want to share what was one way you thought about determining if x minus 3 was a factor? What was one way we could determine if x minus 3 is a factor? I saw lots of different things. McKenna, what did you do? Good, so like one option was synthetic division. So remember, one option would be your synthetic division. And then, how could you notice if it was a factor? What are you looking for in the end?
Remainder is
If your remainder is 0, what do you find your remainder to be, McKenna?
182 x minus 3.
You got 182 over, and then you would have x minus 3. So we were not a factor here. Did somebody do something different besides synthetic division? What else could we have done besides synthetic division? Do we love synthetic? Oh, yes, Evan.
You get positive 3 and you just put it in for all the x's.
Good job. Option 2 would be using your remainder theorem, which would mean you just do 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2. And then if you did that, you should have also found that equals what value? What did that also equal?
180.
Good job. Both ways you find your remainder to be 182. So therefore it's not a factor. So let's look at this different way of this next problem. So lots of different questions that could be asked from our content today. So next question, if x minus 1 is a factor, then we want to factor this completely. So let's start off with kind of, if you were just asked to factor this completely. I have 4 terms, so what might you think about doing to factor this? Grouping, so if I'm like just do this in my head, right? I factor out x squared, I have x plus 4. Ooh, then I have minus 19x plus 14. There's no GCF there, and that is not going to match up with my x plus 4. So grouping wouldn't work here. So what else could we do given that information from our problem? What else could I do if I know x minus 1 is a factor? What do you think, Ruby? If you plug in 1, ooh, that'll only give you your remainder. So you're on to start something. What do you think, Sarah?
You can do f of x.
Yeah, I can just divide by x minus 1, right? So if x minus 1 is what I'm dividing by, you can pick long division or synthetic division. So pick your favorite option or whatever you actually feel like you need to practice a little bit more. I'm going to still just show up or synthetic division. So if I'm dividing by x minus 1, what should be the factor out here with my synthetic division?
1.
Good, just plus 1. Now think about, I have x cubed, which would mean 1. I have 4x squared, which means 2. I have 4. Not 2. I have minus 19x, so I have minus 19, and then plus 14. So bringing that 1 down first, and how are we getting to our next space here with synthetic division? Great job. 1 times 1, it just gives us 1, then adding them together we'll get 5. And then we have 1 times 5 to get us back 5. Adding those together, we get minus 14. And 1 times negative 14 would be negative 14. And what's our remainder equal?
0.
Okay, good. So Ruby's idea with like plugging in 1, that would tell us our remainder, which is helpful to know and understand. If my remainder right here is 0, that's a good check for me right now. Why is that a good check based off of what our problem told us? So this is like me right now, I'm like, okay, you're on the right track, you're doing something right. And how do I know I'm doing it right so far? I got a remainder of 0. Why did our problem tell us we have to get a remainder of 0? Yes, this is a factor, so your remainder has to equal 0. If not, you gotta check your work. So, if I got this, basically what do I know about this f of x function? I know x minus 1 times what gave that back to me. What do you think, Laura?
The 5 x squared.
Yes, it should be x squared, and then what's next? Just your numbers from here. So if you have x squared, and then what would this mean? 5 mean? 5x. And then lastly, we would have, great job. So remember, this was like my answer, right? Which means that x minus 1 times what I get from my answer there equaled back that original function. But guys, we love factoring so much. We want to make sure we can factor this completely. So x minus 1, we have factored all the way, right? That's linear. But x squared plus 5x minus 14. Can we still keep factoring? Probably. What do we probably think those factors could be?
7 and negative 2.
Great. So my other factors are x plus 7 and x minus 2. Cool, right? So thinking about now that original function you have, looking at that from the beginning, you're like, there was no way you could factor it. But now, knowing about using synthetic division or long division, and that was a factor that I had, I could keep going. Devin?
Is the restroom?
Oh yeah, just gonna yell fast.
Middle.
Great. What other questions do you guys have here? Alright, let's look at our next question. Similar, a little different. So, give you a second to kind of think for a little bit. So if f of -4 equals 0, we want to factor this completely. We have x cubed plus 5x squared minus 2x minus 12. So I have 4 terms, so I'm like maybe like, let's see if I can group to just factor. Nope, that couldn't work at all. Right? We couldn't group, right? If I would pull out x squared, it'd be x plus 5. And then I factor out -2, that'd be x plus 12. Those x plus 5 and x plus 12 don't match. So what could I do? What do you think, Sabina?
You divide it by x plus 4.
Yes, Sabina, how did you know that x plus 4 would have been the factor to divide by?
Because f
Great job. So this means your factor is x plus 4. Good. So then it's just exactly like that problem from before, which means we can divide that function by x plus 4. So pick the other method you didn't do on the last problem. If you did synthetic division, try long division. If you tried long division to divide last time, do synthetic division. So give you guys a moment to divide this here, and then we'll see what you got. Alright, so whatever method you did, no matter what did you find your remainder to be? Good. And our problem told us, hey, you should get a remainder of 0. If not, check yourself. So maybe you used synthetic division. If you did use synthetic division, what was like that number you had all the way out there? Like on the outside of your L? -4, right? You flip the sign here, or just know you kind of were told it right here from the beginning if you used -4. That's it. So you should have found that x plus 4 times x squared plus x minus 6 gives you back that original function. So we want to factor completely. So x plus 4, no way we can keep factoring. Can we keep factoring x squared plus x minus 6? Yes. What would those factors be?
3 and -2.
Great job. X plus 3 and x minus 2. And that is our examples for today. What other questions do you guys have here? Alright, so I'm going to let you guys pick for the last like 20 minutes of class what you would like to work on. So I'm going to give you some options. So option 1 is going to be your Delta Math homework. Right, you should be up to your long division by here. Option 2 is that classwork from last time. Option 3 is your quiz review, and there's a key posted on Schoology. Or if you feel pretty good about the content and you have like your Delta Math almost totally done already because you're kind of looking ahead, I have 2 challenge problems for you that you could be working on instead.
Would these be on the